Hello everyone, welcome to another episode of Mr. Brown's Secondary Science. Today we are doing half-lives of radiation sources. Now you may come across a graph that looks something like this. It's telling you that this is the decay of a radioactive sample. It's giving you an axis of time, this time in days along the bottom, and it is giving you an activity of a radioactive sample. Now, what do we mean by activity? First of all, well, radioactive samples, they give off radioactive particles. So here we have an alpha source. You can see I've drawn two alpha particles coming from that source, and they are detected by something. Now the rate, in other words the number that's produced in a certain amount of time, is the rate of the radioactive source. It is its count rate. So here you can see two being produced, and that could be in a second. So the Geiger counter, how you'd measure this, and you can see it called a Geiger counter or a Geiger-Müller tube, that detects those particles. So it can detect how many of them are being released in a certain time. It will tell you your count rate. Now, over time, the radiation source will run out of atoms. It will run out of atoms that decay. So the number of particles that is given off will reduce. You can see I've got rid of one. So now rather than 2 in a second, it would be 1 in a second. When this count rate halves, that is your half-life. The time it takes to go from one reading to a reading at half that level. So let's go back to our graph. Now in this graph you can see we have activity. Now it's measured in a unit of becquerels, which is a measure of radioactive activity, but don't worry too much about that. We're just looking at the numbers. And along the bottom we can see the time in days. Now at the start we have an activity of 80 becquerels, so 80, and we want to find out how long it takes to get to half of this. So if we divide 80 by 2, we can quickly see we need to know how long it takes to go from 80 becquerels to 40 becquerels, half of that. And if we look at our y-axis, we find 40. We look across. This is the point on the graph at which we have our half-life. We read down, and I'll use a ruler for this just to be neat. We read down and we can see that it took 2 days for the activity rate to half. So the half-life of this sample is 2 days. That's all there is to it. Look at your activity at the start, halve it, find that half figure on the same axis, read across, and then count how long it took for the sample rate to half. I said sample rate, I should have said count rate, but it's how long it takes for this activity to half. And to repeat again, it was 2 days here. If there's any questions, do let me know in the comments below. Remember to subscribe if you find this useful. If you want anything, or if there are any topics that you would like me to go over, please do let me know. That's another episode of Mr. Brown's Secondary Science. Thank you very much.